So now that we have our node established and connected to the Fabric Connect network, we want to go ahead and add configuration and fault management. As you can see, we have two potential paths across the network from point A to point B. And as you can see, we have two backbone edge bridges, ERS-8800-2, which has already been created and already has services established, as we've shown in the previous video. In the future, ERS-8800-4, the node we are configuring, will become a backbone edge bridge. It has a skeleton config today, which is basically the same thing as what ERS-8800-1 and ERS-8800-3 have, which is basically SPB enabled, ISIS adjacencies established, and configuration and fault management enabled. We're going to go through that on ERS-8800-4 because we do want to have proper end-to-end configuration and fault management diagnostics. The reason for this is, as you can see, there are two potential paths across the network. You also will recall that we created two backbone VLAN IDs. This gives us two potential paths for equal cost multipathing across the network. It's important for us to have insight as to the potential traffic paths and how different traffic will occur and different services will utilize these equal cost paths across the network. CFM helps us to diagnose that. This is the focus of this particular series. As you can see, we have brought up a prior command of the ISIS LSDB, and we have three other nodes that we're connected to. And here are our human-friendly ASCII labels, which are ERS-8800-1, 2, and 3. As you can see, we can run diagnostics to each individual point, but for the purposes of this exercise, we're particularly interested in the pathing behavior between ERS-8800-2 and ERS-8800-4. The first steps to gain insight into that is, of course, setting up configuration and fault management. We're already at the configuration prompt. So setting up configuration and fault management is a fairly simple affair. It basically is comprised of two particular commands, CFM SPBM enable, which allows us to run configuration and fault management at the BMAC level within the networking environment, and then also CFM CMAC enable, which is an enhanced feature to run 802.1 AG outside of the SPBM domain to query connectivity to customer or client MAC address environments, i.e. those MAC addresses which are outside of the SPBM network. Now that we have those enabled, we can do a quick show on, first of all, let's show the CFM for SPBM. We are actually referencing the BMAC address that we assigned to our node earlier. The only delta is you can see that it is represented, rather than in a dotted decimal, a colon delimited format is in a proper BMAC format, or proper MAC address format. Let's run the secondary command, which is basically show CFM CMAC. And as we can see, we also have a MAC address that's associated, but in this instance, it's associated with the edge of the network address, which allows us the ability to run the CFM connectivity diagnostics outside of the actual SPBM domain. The next step is to actually exercise some of the commands. The first one we'll look at is L2 ping. This is basically a very simple connectivity check similar to an IP ping. In this instance, we're going to specify the VLAN, and as you recall, we set up two backbone VLANs. We're going to specify the query via the first potential path, which is 3998. We will specify our router node name, and we will use ERS-8800-2 as our query destination point. And as we can see, we have success. This validates that there is connectivity over the backbone VLAN 3998. The next thing we want to do is check the connectivity using the L2 ping command over the next backbone VLAN, which is secondary, and that is 3999. And as you can see, we have success on that response as well. This gives us the insight that we have connectivity over both Dijkstra paths. However, we have no insight as far as which potential path those end-to-end Ethernet switch paths are occurring. This is the purpose of the L2 traceroute command. So what we're going to do is we're going to run that command, and it's very similar to an IP traceroute, obviously, except it's done with the layer 2. Again, we will specify our VLAN values, and we will specify 3998 as our primary query, and we will also qualify our node name, and that is ERS 8802. And as you can see, we have a response from the system that tells us the trace route to ERS 8802. So we're moving from our own node, and this is again the importance of the ASCII prompt. We're moving from our own node intermediate through backbone core bridge ERS 8801 to arrive at ERS 8802. Let's run that same command again, but let's specify a different VLAN value, and in this instance we'll just change that to the secondary VLAN, or 3999, and see what the response is. This shows us that we are actually reaching ERS 8802 through an alternate node. So this basically gives you the ability to diagnose the Ethernet switch path, and this becomes important when you start tying in the different logical services, particularly if you're aware of what the link state database is telling you and how the actual load sharing happens for the particular services within the Avaya Fabric Connect network. We'll show further insights to that on further videos, but this gives you the diagnostic foundation in order to actually look at the way data plane forwarding happens within the actual Avaya Fabric Connect network.